In this video, we're going over derivative rules that you must follow when taking the derivatives of functions without using a definition. This just makes it a lot easier instead of having to use a definition every time. So first of all, it's a constant rule. So basically, when you're taking the derivative of a constant, it will always equal 0. So say we're taking the derivative of 2. The derivative will just be 0, no matter the constant. If there's no x, it'll be 0. And second of all, is the power rule. So basically, when you're taking the derivative of an x with an exponent, you do this little maneuver where you bring the exponent down, make it a coefficient, and then you keep it up there, but then you subtract 1. So if we're taking a derivative of, let's say, x4, x to the 4th power, we'll bring the 4 down, 4x, and then we'll keep it up there and then subtract 1 from it. So this will be our derivative, 4x to cubed. And next is the power rule when n equals 1. So when there's just no exponent, the exponent's just 1. Typically don't write it out. So let's just try it. Let's see, f of x equals 3x. So let's do the power rule with it and then see why it only equals well, when the power, okay, what it says is power rule when n equals 1, it will always equal, like the derivative will just be 1. So let's try it. So it'll be f of prime x equals 3. So there's nothing to bring down. Well, you bring down a 1, but 1 times 3 is 3. And then anything to the power of 0 is 1. So just be 3 times 1. So the derivative is f of x times 3. Now f prime x equals 3. That's the derivative of f of x is equal to 3x. So basically, you just take away the x when you're using the power rule and the exponent is just 1. Okay, constant multiple rule, similar to the power rule, but say you're taking the power of f of x equals 3x to the cubed. All right, you do not take the power. You do not take the derivative of the 3 coefficient. You don't do anything with that. You just leave it there. Just leave it there. Ignore it. Separate it. Whatever. You bring the 3 down. You bring the exponent down. 3 times 3 x, and then you do the power rule, so it's 2. So this would be 9. Okay, now you actually do something with it. Now you actually multiply it, so then it'll be 9x squared, and this will be the derivative with the constant multiple rule. The sum rule is when you have 2 functions and you're adding them together, so when you're taking the derivative of them. So basically it looks like this, f of x plus g of x equal to, so this is it, it'll be f prime of x plus g prime of x. So you're still adding them together. That's just you're adding the derivatives now. And then this difference rule is quite literally the same thing, except with subtraction. X plus g of x. And we'll do an example right now. All right, so say we're taking the derivative of f of x equals 2x squared, and g of x. We'll just do 1. We'll just do the sum. So g of x is equal to x4. Okay. So if we're adding them together, so if it's 2x plus x4, we're going to take the derivative of them individually, so split them up. So this derivative will be, bring the 2 down, 4, and then subtract 1, subtract 1 from the exponent, so it'll just be 1 to the power of 1 plus derivative of x to the 4th power, which would be 4x cubed. And this will be the derivative of those two functions added together, and the same concept with the differential, just with subtraction. Alright, and then the derivative of sine rule. This is what's the derivative of sine? It'll always be cosine x. And then cosine, the derivative of cosine will always be negative sine. So it'll be derivative of sine is positive cosine, derivative of cosine is negative sine. So if you have, I don't know, you have 3 f of x equals 3 sine x. Derivative will be 3 cosine x, and it's as simple as that. And same with the sine, and same with the cosine. We'll do f of x equals 4 cosine. So this time, since there's a negative, you take that negative out, you put it in front of the coefficient, so it'll be f prime of x negative 4 sine x, and that will be the derivative.